And so this quadratic expression, you can notice that the coefficient on x squared is not 1. So we're going to use this factoring by grouping, which means we have to break up this minus 13x into two separate terms. So remember, the two numbers that we're looking for multiply together to give you the product of the coefficient on the first term and the constant term. So again, I'll just call them a and b, but they multiply together to give you 6 times 6. Since this 6 comes from the coefficient on x squared, and this 6 comes from the constant term. And then these numbers are also going to add up to the coefficient on the x term. So in this case, minus 13. So let me just rewrite our multiplication here. This is just 36. And like the last problem, we're just going to write out all the factor pairs of 36. So it could be 1 and 36, or it could be minus 1 and minus 36. It could be 2 and 18, or they could both be negative. It could be 3 and 12, and in all these cases, they could also both be negative. And 4 goes into this. 4 times 9 is 36, so minus 4 and minus 9 would work. And of course, 6 goes into it, and minus 6 and minus 6 would work. So now, out of these pairs, which of these would actually add up to minus 13? And you might notice that would be this pair right here, minus 4 and minus 9. So it doesn't matter which you call A and which you call B, but those are the two numbers we're looking for because we want to break up this minus 13x term into two separate terms. So we have 6x squared, and instead of minus 13x, we're going to write minus 4x minus 9x plus 6. And like I mentioned above, if you wrote the minus 9x first and the minus 4x second, that would be fine as well. You just want to follow the same process. We're going to group the first two terms together and the second two terms together. And then we're going to factor out the greatest common factor from each of these pairs. So in this one, well, they both have at least one x, so we're going to factor an x out. And 2 would divide into both 6 and 4. So 2x is the greatest common factor of this pair. And when you pull that out, you're left with a 3x there and a minus 2 there. And over here, the greatest common factor, it looks like 3 goes into both of those. And I'm going to pull out the negative as well, just so that when we write our x term, it's not going to have a negative coefficient. So I'll pull out minus 3. And so this becomes positive 3x, and this becomes minus 2. If I hadn't pulled out the negative, then this would actually be the opposite of this. It'd be minus 3x plus 2. And then from there, you might realize that to get them the same, you can pull out the negative. But with experience, you tend to notice that stuff ahead of time. So now looking at this quadratic expression with it being factored, notice there are now two terms, this first one and the second one. And both of these terms share a common factor, this 3x minus 2. So we're going to factor that out from both of them. And when we pull it out here, so 3x minus 2, we're factoring that out. We're left with just a 2x. And over here, we're left with minus 3. So this is what we think is the answer. But again, we're going to have to multiply it out just to check our work. So let me just write that down. We're going to check now. So let's distribute the 3x, or you could think of it as the FOIL method. And 3x times 2x is 6x squared. 3x times minus 3 is minus 9x. Minus 2 and 2x would be minus 4x. And minus 2 times minus 3 would be positive 6. And notice the middle terms do combine to give you minus 13x. So that tells us that for sure this is the right answer. And you really only know for sure if you remultiply it back out and you get back what you started with. So let's keep going. We'll do more examples here.